Hi, everybody. I just wanted to run through real quickly here the max and min problem and make sure you had some idea of how it works. This is a super important program for us, even though we've just learned about arrays, because it really kind of focuses in on one of the main elements, one of the main strategies that we use whenever we work with arrays. We're always trying to find, it seems like, the maximum or the minimum of something. Sometimes we're counting the number of items. And so this is a great little program just to kind of introduce that idea. So we're going to create a program, max and min, not a class. Create an array of 10 integers chosen randomly here. We'll talk about how to do that. And then write a loop that runs through, and we'll be looking for the largest and smallest values and also where they are located in the array. And here's an example of what the output might look like there. And then they identify the largest value is at the index 0 and the smallest value. And we can see that that's what's happening there. So how do we actually make that happen? Let's go ahead and see if we can run this. I'm going to do this in Visual Studio Code, but of course you can use this in BlueJ if you like. So public class max and min is what we're working with here. Yeah. Um, because this is the program, we'll do public static void main and string and args and we'll get all that taken care of. And so what am I doing in this program? Let's see. First thing, I need to create an array of 10 integers chosen randomly here. So let's set up the array. Remember that we have a little two-step process. We can say int um, values, vals, is equal to a new integer array int, and then in the square brackets, we put how many values we're going to be keeping track of there. We can do that in one line if we like. We can split it up into two lines, but this is pretty classic here. If we know we're going to have 10 values, we'll do that. And I guess I need to go through that whole array now and choose a random number between -100 and 100. So let's see. If I'm going through the whole array, that always means a loop. For int I equals 0, I less than, and I could say 10. That would go from 0 to 9, which would work. But let me go ahead and use vals.length without parentheses. That's a great little defensive programming mechanism. That way, if we adjust the length of vals later on, this array loop will automatically adjust to handle that situation. So that's really valuable for us. And I guess what we're going to do is we're going to get a random number between -100 and +100. A little bit tricky there. We're going to store that number in vals sub I. So when I is 0, we'll set vals 0 equal to one of these random numbers. Then I will go up to 1. We'll set vals 1 equal to one of these random numbers. So this should go through and figure all that out for us. Let's figure out how to get a random number between -100 and +100. A little bit tricky here because I guess I could do random numbers, right? If that was 10 numbers, if I was going, say, from -10 to +10, then I could do that, or -3 to +3. I want to think about that a little bit, though. I'm actually going to call this up so I can draw on the screen a little bit here. Let me think about that for a second. Is that what I want? Yeah, there we go. So if I was going from, say, -5 to +5, how many random numbers or what range of values am I choosing from here? I'm going from -5 all the way to -1. That's 5 values. +5 down to +1. That's 5 more values. And 0 is also an option. So there's one more value in the middle. In other words, I'm going to have 11 numbers that I'm choosing from. So one of the ways I can do that when I write my program is I can say, let me get oops, I didn't mean to do that. Math, oh, that's funny. Sorry, let me get rid of this. Math.random times 11. That's going to get me 11 numbers, 11 random numbers from 0, once I do the int on it. Maybe I'll do the int here. I'll be sure to include that in there. int math.random times 11. That'll get me random numbers from 0 to 10. But if I want to make it -5 to +5, I guess I would have to subtract 5 from that. So yeah, so that would take me, if I get 0, that'll take me all the way down to -5. If I get 10, remember this is 11 values from 0 to 10. If I get 10 and subtract 5, that'll give me the top number 5. I think that'll work for allowing me to get 0 in the middle there. But of course, I'm not trying to get 0 in the middle. I'm trying to get, or I am trying to get 0 in the middle, but I'm not trying to just get 11 numbers. I'm trying to get -100 to +100. I guess that's 100 values here, 100 values here for 200, and the 0 in the middle, 201 values I need to go through. So 201 values. And if I subtract 100, that'll get me from -100 to +100. If that seems a little bit weird to you, you can spend a little bit of time going over that. And then let me go ahead and write another loop just to print that out and see what's going on. What did they do in the sample here? The array of random values. So I'll go ahead and do that. I'll play that game. System.out.println, the array of random values. And then how do I print that out? I guess I'm going to do that same thing. I'm going to go ahead and copy that loop down here. And yeah, let me put that down here. And instead of creating the random numbers, I'll just print the random numbers. System out print line, or print rather. I'll print each time I'll print val sub I, and then I'll put a little comma space there. And then once I've gone all the way through the loop, maybe because I'll still be stuck on the same line, I'm going to system out print line. I'll go down to the next line. Let's see what that looks like. There we go. See what happens when we run that program. This is max and min.java. I guess I'll go ahead and put that in my APCS folder inside a folder called max and min. Awesome. All right, let's run it, see what happens. Hoping I get 10 random numbers, all between -100 and +100. And we're compiling, and the array of random values, there it is. Ooh, I got down to -100, got up to +97. So it looks like that's working. And every time I run that, I should get another array of values there. It does print out a little extra comma at the end, but that doesn't bother me. Cool. Those are my arrays of random numbers every time. So now what I need to do is get into the real heart of the problem. Now that I've got an array of random numbers, how do I get the location and the value of the largest value and the smallest value? Well, that's an interesting little question. Let's obviously I'm going to need to go through the array. So let's set up another loop and see if we can do that analysis. I'll go ahead and close this in the meantime. And we'll say for int I, well, actually, yeah, I'm going to go through, but I need to find out. I guess I need variables to keep track of maybe where the smallest values are and where the largest values are. Let's try that. So I'm going to do int smallest loc is equal to, so this is going to be the location or the index, smallest index. And at the beginning, when I'm going through the numbers, let's think about going through some numbers. Let's pretend I was going through these numbers right here. At the beginning, as I start to go through here, I'm going to look at these one at a time. And the very first one at the beginning, that's the smallest number I've seen. So I'm going to say the location of the smallest number at the beginning is just that 0 value. And as long as I'm thinking about where the index, the location of the largest value, I guess that's the largest index as well. The location so far of the largest number I've seen. There it is right there, 95. So for both of those, I'm keeping track of where the largest and smallest number is located. And at the beginning, it's at that 0 position. So now what happens when I go through the loop for int I equal, and I guess I want to go through all the positions, but I don't have to go through the first position because I've already checked that out there. So for int I equals 1, I less than vals.length. I'm going to go through I plus plus. And every time I get another number there, I want to compare the number there with this value here. Is that right? No, I want to compare the number at that location with the number at this location. So let's think about that. If vals I, the number at position I, the number at position 1, is greater than the number at position 0, or the position at smallest index. Smallest index right now is 0, but later on, I'm going to be changing that as I go. For instance, if vals I is, oh, I'm sorry, I'm supposed to be doing less than. If vals I is less than the value there, if this negative 23 is less than 95, I need to save this location as the new location of the smallest number. And how am I going to do that? I'm going to say smallest index, the smallest index I've seen so far, the index of the smallest value I've seen so far, is now at that 1 position, is now wherever I has been set up. Cool. So yeah, so this is going to say if the number where I'm looking now is less than the number at the location that is marking the smallest value, then save this as the new location where the smallest value is located. Remember, the I gets stored into smallest index. And I want to do the same thing for the largest, I guess. If the number that I'm looking at now is greater than the number at the largest index, then save that number. Then the largest index is going to be equal to that I value. And I'm going to go through. I'll just keep on going through. And I think that'll work every time. I'll keep on going up farther. I'll check to see if this is larger than the largest number I've seen so far or smaller than the smallest number I've seen so far. And each time I'm keeping track and updating smallest index and largest index to whatever location I have that beats those values there. And by the time I get done, smallest index should have the value or should have the location of the smallest value. And then I can print out something like this. I can print out something like that. Let me go ahead over here. I'm actually going to paste that in there. And we'll try this system out print line. The largest value. And what is that largest value? Where is it located? It's located at the largest index position. So let me go ahead and do that. Val's largest index. Largest index is where it's located. Val's largest index is a reference to the actual number. And then I'll continue. This is at index. And then I'll add in there, it's not 0. I mean, it might be 0. It's at the position largest index. Yeah, I think that might work. And then I'll do the same thing for the smallest value. The smallest value, Val's smallest index, is at position smallest index. Let's see what happens there. Let's see how that works. See if that makes any sense for us. All right, pull this over. Da, da, da. Running. See what happens. Compiling. We'll get the list of numbers first. Here's the list of numbers. And the largest value is 80 at index 4, 0, 1, 2, 3, 4. That looks like that is indeed the biggest number. And the smallest value is negative 65 That's the smallest value as well, and that's at the very end of the list. That's at index 9. This works great. Let me try again. I'll do it once more and see what happens. Now I have a new array of random values, and we can see in this case that 82 is the largest value, and negative 85 is the smallest, and those are the correct indices: 0, 1, 2, 3, 4, 5, 6, and 0, 1, 2. Yep, I think this is our solution. Hope that made a little bit of sense. We're going to be doing that a lot. We're going to be looking through arrays of values and either counting things or trying to identify the largest and the smallest. If we're looking through bank accounts, we're trying to find the bank account that has the most money in it. Um, all these comparisons. This is a classic job for an array and a for loop. We're all set to go.